is the types of columns with respect to loading. So there are two types of columns based on the type of loading. The first one is concentrically loaded columns and the second one is eccentrically loaded column. So in case of concentrically loaded column, load is distributed uniformly over the entire cross section with the center of gravity of the loads coinciding with the center of gravity or centroid of the column. So here the load is considered acting at the centroid of the column. So this is the ideal case that the load is acting at the centroid of the column. So if the load is acting at the centroid, so we can call it as a concentrically loaded column. So it is the ideal type of load on a column is a concentric load, and the member subjected to this type of load is termed as a concentrically loaded column. So there is a possibility that the interior column of a building may be a concentrically loaded column, because in that case the area supported by this column is same on all four sides in most of the cases. And the bracing elements, they can be a concentrically loaded column because we can design the connection in such a way that the load may act at the centroid of the section. Similarly, the truss members can be a concentrically loaded column because in that case we have a pin connection, so the load can be assumed to act at the centroid of the column. So these are the ideal cases in which we can say that the column is a concentrically loaded column, but in most of the cases the column is not a concentrically loaded column. There is always some possibility of eccentricity of the load, mean the load is acting away from the centroid. Next is eccentrically loaded column. So if the center of gravity of the load does not coincide with the centroid of column, so then it is termed as eccentric column. So here this is the centroid, but the load acting at a distance e from the centroid. So this type of loading is termed as eccentric loading, and such column is termed as a eccentric column. And the distance from the centroid up to the point of action of the load or line of action of the load is termed as eccentricity. So the axial loads as well as bending moment act on the column due to eccentricity of load. So because of this eccentricity, this distance between the load and the centroid of the column, there exists a bending moment. So this P time E will produce a bending moment M in the column. So in that case the column is simultaneously subjected to axial load as well as bending moment. So in practice majority of the columns are eccentrically loaded compression members. So mostly the columns are eccentrically loaded columns. The eccentricity may be small or large, but the eccentricity exists, or we can say eccentricity always exists in the columns.